So yeah, that's what it kind of looks like. There's a picture there. And I know that this is not how you're supposed to show PowerPoints, but it turns out it's a little bit, oh, maybe I can actually play it. Let's see. See if it actually works. Is it a video? It was a video one time. Yeah, it's no longer a video. Anyways, okay. So let's talk about constant positive velocity. Now you'll notice that there's a little simulated ticker tape thing there. I'm just going to read the top part. I won't do it for everyone. You've got it all on paper. Okay, some of you have figured out that you need to draw this. That's fine. Observe that the object below moves with a constant velocity in the positive direction. Positive being to the right. The ticker tape shows that each consecutive dot is the same distance apart. So you should draw something like this that shows the dots evenly spaced. Okay? I don't care if the number of dots matches or not. All I care is that the dots are evenly spaced. The position time graph shows that the slope is both constant, meaning a constant velocity, and positive, meaning a positive velocity. The velocity time graph shows a horizontal line with zero slope, meaning that there is zero acceleration. The line is located in the positive region of the graph, corresponding to positive velocity. The acceleration time graph shows a horizontal line at the zero mark, meaning zero acceleration. Now, if you're currently drawing, you need to stop and listen. Okay? So, the position time graph, you will notice, down here, starts where? Starts at 0, right? And it's a straight line. What does the straight position time graph indicate? Constant velocity. This graph matches this ticker tape. The velocity time graph, what kind of line is it? It's not only straight, it's starts with F and then flat. Flat. The velocity time graph is flat because the velocity is staying the same. In fact, it's about 11 or 12, right? What property of this graph would be above 11 or 12? How would I get 11 or 12 out of this graph? No, I would calculate the slope. The slope of that graph would be about 11 or 12, and it would be 11 or 12 throughout, right? Throughout the entire graph. And that's why my velocity time graph is flat. Why is the acceleration time graph over here flat? Not changing velocity. In fact, what is the slope of the velocity time graph? 0. What is the value of the acceleration time graph? It's right at 0. It's right at 0. Okay, the next one here is constant negative velocity. You'll notice that the dots are again evenly spaced and moving to the left. My apologies. Okay, so constant negative velocity. I'm not going to read the top part. If you're restudying, looking over this, you can go ahead and read that. I'm going to give you my version. The dots are moving to the left. Somehow indicate that on your little chart thingy there. They are evenly spaced because it's moving at a constant velocity. It's moving left. It's negative, right? The position time graph, you will notice, starts at 0. Where's my origin? Up here. It's over there where the little plus sign is, right? That's where my 0 is. Why is the position time graph below? Why is it negative? It's moving to the left, exactly. Why is it a straight line? Constant velocity. If you had to guess approximately what would be the slope of this position time graph, what would be the approximate value of the slope? Anyone? I'll give you a hint. About minus 12, exactly. How did you get that? Because the velocity time graph is a graph of the slope. What value is the velocity time graph? It's a constant minus 12. How come? Because the slope of this graph is constant minus 12. What's the slope of this graph here, Riley? Constant what value? No, the slope. What's the value of the slope of this graph? So the value is 0, which means my acceleration time graph is a constant 0. Nod and say, yes, I get that, Mr. Ben. You don't have to say, just the nodding is saying that, yeah? Okay? Are we good? Now, so, here's a question for you. Can you tell from the acceleration time graphs of the last two which way the object is moving?
No.
You can't. Can you tell from the velocity time graphs which way it's moving? Yes, one is positive, one is negative. You can tell a lot from a velocity time graph. I'm going right to the bell today, you guys. Constant. What's the next one? Positive velocity, positive acceleration? Okay. Positive velocity means it's moving to the right. Positive acceleration also to the right. Where are the ticker tape dots? Spread apart. Because it's speeding up. Listen for a second and then drop. They're moving apart, they're speeding up. What does the position time graph look like? It's curved. Curvy position time graphs mean they are speeding up. Could we find the slope of this graph? No. Why not? It's changing. So if I were to find slope there and slope there and slope there and slope there and slope there, I would find that the slope is increasing. The velocity time graph is a graph of the slope of the position time graph, and you can see that the slope value that we're graphing is increasing. It starts at 0 and it goes to about 24 or 25. Does the velocity time graph have a constant slope? It is straight. It has a constant slope. What is the value of the slope of the BT graph approximately? I went too far. Go back one. Go back. I know, I want it to go back. I'm trying to get it to go back. I won't go back. Go back. Okay, so what is the value of the slope? Oh, I cut it a little bit short here, didn't I? What is the value of the slope? Can you tell from the acceleration time graph? Approximately, Peyton? A rough guess? No, go ahead. The acceleration time graph over here on the right, my cursor's going here. The acceleration time graph has a value of about what? 1. How come? Because the slope of this line is? And has a value of? About 1.7. Because the acceleration time graph is a graph of the, starts with S, ends in slope of the velocity time graph.
What's a good time to come and chat?
As soon as this class is over.
Okay, perfect.
You want to hang around, actually.
Yeah.
Are we going to get to this one? Positive velocity, negative acceleration? Or you haven't written this one down?